Okay, we start off in weather with monitoring the weather. We're just going to give you a basic overview of weather this week. So, with that in mind, let's see what we can look at here a little bit. So, weather. Well, weather is a state of the atmosphere at exactly one place and one time. So, when you walk outside your door, what you feel is weather at that location, at that specific moment in time. And guess what? If your neighbor walks out their door, they're going to feel something slightly different because weather is different from location to location. And maybe they come out a couple hours later and it'd be totally different. We know temperature changes during the day, humidity does, cloudiness, precipitation, wind speed, and wind direction. All of these are quantitative variables that we're going to talk about throughout this course. So meteorology is basically the study of the atmosphere and the processes that cause weather and the life cycle of these weather systems. Climate, on the other hand, is longer term. We look more at 30-year averages, and if you haven't noticed or haven't read anything in the last month or so, the National Weather Service has issued a whole new set of normals for temperatures and winds and all across the United States. They do it every 30 years. So how do you access your weather information? Well, sometimes you get it online. Smartphones have it all over the place, even television. One of the things, notice I mentioned that weather is what's happening now. So in order to talk about weather, the meteorologists have taken the custom of putting everything in Zulu or universal time. That is the time that it is at Greenwich, England, or 0 degrees meridian. For Eastern time at 7 a.m., that would be the same as 12 noon at Greenwich, England. So we would call that 12Z. So every one of the observations on a 12Z map is exactly at 12Z. So out in the Pacific, that would be at 4 a.m. in the morning. Here in our time zone, it would be at 7 a.m. in the morning. Now, if you go to Eastern Daylight, it changes 1 hour, so it becomes 8 a.m. And it would be 5 a.m. out in the Pacific. There are two basic types of weather systems, too. There's a high pressure and there's a low pressure. Highs generally bring fair weather, and the winds rotate clockwise around the high. So if you're on the northwest side of a high, you're going to have winds coming out of your southwest. If you're on the southeast side of that high, you're going to have winds coming out of the northeast. Low pressures, on the other hand, bring clouds, rain typically, or snow, and they rotate the winds more clockwise. Oh yeah, and low pressure typically have stronger winds or storm more. So you think about it here, you have rotation. If you're to the northeast of the storm, you have literally winds that are blowing from the southeast into your area. So what's that pulling in? It's pulling in warmer and moisture air usually. If you're on the back side or the northwest side of the storm, you're going to have northwest winds, northerly winds pulling down colder and drier air. And here's just a diagram of your low and high pressure systems. Air masses. Air masses are under high pressure systems, and they have typically uniform temperatures relatively and humidities, and they cover large areas. We'll talk about how they form here in another few chapters. But there are a couple types. Basically, they form either in the polar regions or the tropical regions, and they can form over land or water. And that is the basic characteristics that they take. If you think about it, if they form up north over Canada, they're forming over cold, dry land. So the air mass is probably going to be pretty doggone cold and fairly dry. Fronts separate air masses. So a warm front means the warm air is advancing. And it typically, as you'll notice here, they're three-dimensional. They don't just are at the ground and then they go all the way up. No, If you were to the north of a warm front, you could still be in the cool sector, and the clouds could be raining on you or snowing on you up here. Cold front are a little steeper typically, but they still don't go all the way up. There's still a slope to them. So that's where one of the things we're going to be talking about is why there's that slope. And some fronts actually can come across with no precipitation. Just a wind shift might indicate a change in temperature or humidity. And in summertime, the temperature change could be pretty small and might be dictated by clouds. Sometimes I can have a cold front pass at my house in summer, and if it's bright, cloudy ahead of it, maybe the temperatures are in the low 80s and there's bright sunshine behind it. Maybe that same cold front, even though it's drier, has temperatures are in the mid to upper 80s. So their clouds influence what kind of weather we're having. And there are lake effect snowstorms that are part of weather. There are coastal areas that get sea breezes or lake breezes too. Lake Erie has one. In the central U.S., they get a lot of tornadoes in the spring typically. Thunderstorms, very common in much of the United States. And we have tropical storms. We might even have one while we're talking about this course. When you describe the state of the atmosphere, you're looking at maximum temperatures and minimum temperatures. Maximum temperatures occur in the late afternoon. They don't occur when the sun reaches its highest, which is at noontime. They occur in the late afternoon because the sun keeps heating things up. Even though it's not as strong, it's still beating down on you. So it's gradually warming you up. Now, when the sun goes away, temperatures fall. Air pressure is another term we're going to talk about. It can rise or fall. If it's a high pressure approaching you, guess what? The air pressure is going to be rising because the pressure is higher in a high pressure and it's lower in a low pressure. Wind direction and speed is another one. Sky cover. There are various types of sky cover. There are all kinds, with high clouds being more icy because the temperature cools with height, and low clouds being more water laden. They look a little darker, not as wispy. And even in fog, which are just clouds in contact with ground. So there are the different forms of clouds, or stratiform, where they're sheets of clouds, and they might be cover huge areas. And then they're cumuliform, like little cotton balls in the sky, puffy. This time of year, you get them all over the place. And then there you have vertical cloud development, like cumulonimbus clouds, which are basically cumulus clouds, but just continually growing up in the atmosphere. Might even have an anvil or a little cirrus at the top of them. And clouds can move in different directions because winds change with different height. They'll move in different speeds and different directions. So let's go over here and let's just look at a weather map a minute. This is the current 12Z on Saturday. So here's low pressure. Notice the winds. The winds are little barbs around symbols. These symbols represent what the weather is at that particular location. And this wind is blowing counterclockwise around this low pressure. Here's high pressure. Guess what? Blowing clockwise around it. Now, I wanted to show you a little bit in Ohio. And it comes up here. Here we go. These are station symbols. This station symbol on the upper left has a temperature. The lower left is a dew point, which is a measure of humidity in the air. Upper right is a barometer reading. It's the pressure. Notice here it's 108. Well, what that means is the pressure is 1010.8 millibars. If the pressure is less than 5, if this number is less than 500, you put a 10 in front of it typically. Now, if it's below, if it's between 999 and 500, you'll put a 9 in front of it. What that gives you is the pressure in tenths of millibars. So you're going to be doing an analysis later this week in your in the labs, and you're going to be looking at these pressures that are on a map. And they're going to either have 10, a 1 or 2, 200 or whatever pressure. And you're going to put maybe a 10 in front of that. But then you're going to have some that are like 890, where you're going to put a 9, and you're going to get 989 point. When you're analyzing that map, all you're doing, and here's an isobar, for example, right here, is 1012 millibars. Everything on one side is lower than that isobar, and everything on the other side is higher. So in this case, the pressure is higher to the north and lower to the south. All you're doing is connecting lines of equal pressure with an isobar. Not necessarily the easiest thing, and I'm sure you'll have some fun with it the first time through. But play with it, get to use it, and get familiar with looking at weather maps, because you're going to be doing a lot of it in this course. Finally, I just wanted to give you a quick look at a GOES picture. This is just a satellite image of what's going on right now. I'm starting off with the simplest one. Basically what's called geocolor, which is like you're literally up there looking out at the sky from above. If you were in a spaceship looking down, this is what you would see. So what you can see here, what I'm seeing here, is a lot of clouds over the eastern United States, basically western part of Ohio, starting to see some sunshine. And you can see a lot of almost like a cold front maybe back in here, and there's a bunch of thunderstorms along the Oklahoma-Texas border, and you can even see the mountains here. They show up very nicely, and a big blob of clouds off the west coast of the United States, probably a low pressure system. So this is basically just your typical satellite picture. We'll get into more details on these satellite pictures as we go along. But you can really just see the motion. You can see some of the lower clouds are moving to the west up here. Some of the higher clouds are moving down towards the southeast. So again, they're different directions of motion depending on what level you are in the atmosphere. So hope you got something out of this. Please don't hesitate to ask if you have any questions.